You see problem 3, force acceleration 3, and I'm going to explain the solution for this problem. It's a quite very long solution. So let's get through this one. So this problem we have two rigid bodies, the wheel or the disc, HGC, translate and rotate, so it's GPM on the horizontal plane, and then block B with that system there. And for this problem, let's call the point at the center of that pulley here ED, and as you can see, that one is the point of contact. And this is smooth pulley, so it's no friction. So the tension in the cable here T1, then that cable also T1, and this is different cable, so that is T2. So that's what we have. So from that we find out the properties. So as you can see, that this is GPM and block translate vertically on the vertical axis, so it's translation. So property for the disc, because they give us the power, so the weight, so you need to find out the mass, divide by G, 32.2 feet per second square. And that one, the mass moment of inertia for the discs, in this case they don't give us the radius of gyration, so we assume that it's a thin disc, and it should be IZZ in your inside cover of the textbook. So for standard shape is a thin disc, IZZ equal to 1/2 of mr square here, so that we can find out the mass moment of inertia. And also the mass for the block, 4 pounds divided by G, 32.2, we get 0.1242 slug. And then the coefficient of static frictions is 0.2. So for two bodies, we draw the free body diagram equal to kinetic diagram for each of the body. So let's go to the wheel. We have the point of contact is A, so we have here A, and the point of contact here is at A. So the T1 I mentioned earlier for the tension, so free body diagram including the weight 10 pounds. Going down, the friction force, we don't know, assume direction, we assume go to the right. Normal force, perpendicular to the surface, so go up vertically, and the T1. In the kinetic diagram for the discs, we have MAGX, because the center of mass onto the center of the discs at G, and that G is move horizontally, so no MAGY, only MAGX, and then it rotation IG alpha. So from that we can have three equations: moment, and in this case the solution, we take moment about A, not about the center of mass. So as you can see, the term on the kinetic diagram, you need to have about A here, so you have to have MAGX times the radius of the disc is 0.5 fit in there, so that's why you have it 0.5 MAGX in that equation. And moment about A, so as you can see, the weight on the free body diagram, the weight, the normal force, and the friction go through A, so only T1 involved in that equation, and it time 1 foot in here, that is 1 foot, because the radius is 0.5, so the from A to point C, from A to point C here. So as you can see, that basically AC and equal to 1 foot. So that's what we had one in there. So that first equation. The second equation, just only y-axis and no MAGY, so it's 0 on the right side. So from that we can have the normal force equal to 10 pounds. And then the sum of all the force in x direction, and assume go to the right is positive, so we have F plus T1 equal to mHEx. So the mass is 0.3106 HEx. And from that, we have 3 equations, 4 unknowns. What are the 4 unknowns? We have T1, number 1 unknowns, T2, not here yet. We have alpha, number 2, and then we have HEx, and number 3, and then friction force, number 4. So we have 4 unknowns because we assume the no slip wheel. So we will check it later, but now, as you can see, always assume no slip disk first, so it equal to alpha r there. So it will be what equation you have there. So that what the unknowns we have for the first free body diagram equal to kinetic diagram of the disks. And then we continue. We cannot be able to solve yet because the number of unknowns more than the number of equation. So we continue to draw the free body diagram for the block, and like I say, it's T2 for the cable, and the tension in the cable, and 4 pounds going down, and this body is in translation, so it no IG alpha, and vertically, so it only MBY, right? MABY, and from that we can have equation in y direction equal to, and assume going up, T2, negative 4 going down equal to negative, because the block going down, MBY going down in there. So that way negative in that. So with that, we have additional unknowns. So we already have 4 unknowns. We introduce another unknown is 5, and another unknown T2 is 6. So as you can see, we have 4 equations and 6 unknowns. Still not be able to solve. So we need to have more. The first thing is the tension in the cable. If we isolate that pulley D, as you can see, so isolate. So if we cut there, and cut there, we have T1 up, T1 up, and then T2 going down from that here. If we sum all the force in Y, so we have T2 equal to TT1. So that nothing new to our statics. So from that, as you can see, we have introduced additional equation T2 equal to T1 without introduce additional unknowns. So we now have 5 equations and 6 unknowns. Still not be able to solve. We need to find some other kinematic relationship. So the first kinematic relationship is, we talk about the relationship here is the pulley D, as you can see there, pulley D. So in this case, it no slip on the point opposite of H in there. So from that, we draw that pulley D, and as you can see, the point H. So what we can have is, because no slip on this point, then we have AD at the center of that pulley equal to alpha of that the angular acceleration of that pulley times the radius of that pulley. And then we AD, as you can see, hook to the block B, as you can see there, D hook to block B. So whatever D move down with the acceleration ADY, the B also have the same acceleration ABY. So from that, we have equation is AD equal to ABY. So that, so far we have that kinematic relationship for when we're talking about pulley D. And then we also have the what is the acceleration AH. Why we need to find out the acceleration AH? Because as you can see in the whole system, H connect to point C with the cable T1 in there, in connect to point C there. So whatever the acceleration h in terms of kinematic relationship going down, the acceleration of c in x direction go to the right, it will be the same because they go hand in hand with the cable. So from that one, you want to find out what is the acceleration h and that implication for acceleration of c in x direction. So use the relative acceleration equation that you study in the particle kinematics 2 relative equation. So AH equal to AD plus AH over AD. AH is, we don't know, so we break it down into X and Y. And then AD, we know for sure it's going down vertically with the block, so it will be, and at the same time rotate about the point of contact for the rope on the right, so it will be alpha of the pulley dh times the radius, and then ah relative to d, we as if d were fixed and h rotate about h rotate about d, so we draw the kinematic diagram with that. And because the and there are two unknowns, sorry, two components of acceleration, alpha r, tangential component, and normal components, omega square r. Because start from rest, so you don't have the normal components of the acceleration for ah relative to d, so you only have alpha r, alpha dh times the radius in there. So if we sum on the vector in y direction, so you have ahy equal to negative, because going down alpha dhr, and also going down on the ah over relative to d tangential components, also alpha dhr. So that one is alpha dhr. So it will be equal to, because alpha, as you can see, alpha dhr equal to ad, so from that it equal ahy equal to negative 2ad, because add them two equal to negative 2 alpha dhr, alpha dhr equal to ad, so it will be negative 2 ad. So far we introduced the more unknowns and then more equation. As you can see, so far we have 5 equations, and then we have this additional 2 equations, so you have 7, and then we have this equation, so you have now 8th equation. But we introduce more unknowns, you can see here, ad, alpha dh, and ahy, right? So you have in there, we stop number 6, and then you have number 7, number 8, and then you also have here number 9. So we have 9 unknowns, 8 equations, still not be able to solve. And then we need to find more kinematic relationship. In this case, the non-slip discs, the non-slip discs. So as you can see here on top of this disc, and A is the point of contact for non-slip, and G the center of mass. So we want to find out AC of this one. We have AC of this one equal to HE plus AC relative to G. So again, relative acceleration for the disk, and similar to the process we find out AH, so it will be ACY, ACX, and then HE move horizontally, so it will be HEX, right? HEX equal to 0.5 alpha d, because we assume no slip. This is, we already assume originally no slip. This is no slip disk assumption. We will check it later, right? And then the same for ACG, to draw the kinematic diagram at its G fixed. So we have that 0 because the that one alpha square r, because at rest, initially at rest, So we don't have omega 0, so omega square are 0. The normal components equal 0, and the tangential components equal to alpha d. So from that, d is the disks. So from that, we can add 2 in x direction. So ACX equal to 2 alpha d times radius, so 0.5 alpha d, 0.5 alpha d, 0.5 alpha d. So you have 2 alpha d, and radius is 0.5 foot. That 1.5 for the disk. So you have 2 AGX, 2 alpha d r, because as you can see, that one basically AGX direction. So that equal to AGX, and from that we have AGC equal to also AGC equal to AHY, as I stated earlier, because that one in terms of kinematic relationship, C hook to H on the tension of the on the cable there, so they go hand in hand. So whatever C in x direction horizontal move to the right with the acceleration ACX, acceleration H in y direction AHY vertically down will be the same. So from that we have that kinematic relationship is very important. They go hand in hand. So we have ACX equal to AHY. So now we have 10 equation, because that one we have that number 10 in here, and we have 10 equation, 10 unknowns. So from that we can solve for this one. But how can we solve for 10 equation, 10 unknowns? Just give it, as you can see, we replace all of the acceleration here with the ABY, so all of that we see the relationship with ABY, because you see AD equal to ABY, AD equal to alpha DHR, and then AHY equal to 2AD, and AD equal to ABY, so it alpha HY equal to negative 2ABY. So do the same, we can have it, as you can see, AHY equal to, in terms of magnitude, ACX equal to 2ABY, because ACX equal to AHY there. And then HG equal to ABY, from above. So alpha this equal to HG over here. Also, because no slip assumption, right? No slip disk assumption. Otherwise, we don't have that equation. Keep that in mind. And from that, we can plug into the very first equation we have, which is equation number 1 for the MA, moment about A. Equation number 4 in here. Sum of all the force equal to AX F T1 MAGX, and then we have number 5 equation. Sum of all the force in y direction for the block B, T2 minus 4 equal to negative 1242 ABY. So when we have that equation, we can plug into, we have that 3 equation and 3 unknowns, which is T1, we have ABY, and we have friction. So from that we can, because T2 equal to 2T1, right? T2 equal to 2T1. So you have that, we rearrange for that. So we will find out T1 equal to 1.579 pounds. T2 equal to double of that. ABY equal to 6.78 feet per second square, and the friction equal to 0.527 pounds. And we have to check our assumption, because we assume no slip disks. So we find out have to be less than at max mu sub Sn, n equal 10 pounds, that we already find out very first unknowns in that equation, as you can see there. So from that we can have mu sub S equal to 0.2. So we have it 0.2 times 10 equal to 2 pounds. compared to the friction force here, 0.5 to 7, so it's less than F max. So assumption is good. It means the disk no slip, right? It means this does not slip. So from that is our solution. And the question asks is what is the velocity of the question is what are the velocity of the block. Determine the velocity of the block when t 2 seconds. So we have acceleration aby, right? Find velocity, we take integral with regard to time. So you see basically aby, and they ask us what is the acceleration of so velocity of vby after 2 seconds, t equal to 3 seconds. So from that we can have integral and equal to 20.3 feet per second going down, and that should be the answer. And you can see very long problem. If you master all of this concept in this problem, I'm very confident that any force acceleration problems in this class you can be able to tackle with, as you can see. So there tend to be more unknowns than the number of equation. That the bottom line, you need to look for the many kinematic relationships and use your knowledge in statics to really tackle and solve this complex problem, and use this concept for the any force acceleration or even the future work energy and impulse momentum problem, because we also deal with the kinematic relationship for kinetic problems in future.